and very good afternoon to all of you. Right now, there are 27 students, 26 students. Okay, I think half of the class right now. So I don't know whether the other half is planning to withdraw the course or not. I don't know how the test, because I haven't yet marked your test one. So I don't have any clue. But I think that one is straightforward. Some of the question is straightforward, and as mentioned earlier, also in the class, there are one questions, okay, that a tricky questions, okay, one sub questions. For example, Q1 and Q2, there are one part of that question that is tricky, okay, just to differentiate between the good students and also a normal student. Okay, so just to confirm to you all that for us, for if the topic has been tested in the test 1 and also your test 2, so the topic will not be in your final exam. Okay, so meaning that you can you can ignore, not ignore, you can actually get relaxed, okay, in terms of to study for the final exam. So meaning that the magnetic circuit, so you can do not focus on the magnetic circuits lah. But that magnetic circuit is the basic for the next course. Okay, for example, you are, I think, SKEE, right? Most of you SKEE, if not mistaken. So most of you will actually take the basic machine course, okay, for a second time. Okay, that one will be more detailed, and we will do the same thing in that the concept of the magnetic circuits and so on. So you actually will go through again, okay, but more detailed. Okay, okay, this one. Do we need to attend face-to-face class after week 9? Okay, this is the very popular questions that I have received, because I teach 2 courses. Okay, I have received these questions during week 1 and week 2. Okay, the early session. I think not from this course. I think there are students from overseas, from Bangladesh, from Pakistan, and so on. So they are worried whether they required to come into the campus, because the status of the course for this SEE2423 is also, as you can see, the status is blended learning. Blended meaning that it can be face-to-face, and in some part it can be face-to-face, and in some part it will be online. So so it's quite, for me, I agree, it's quite confused. Okay, the lecturers also got confused, the students also confused. Okay, and then we know that week 9 the student will start to come into the campus. They are allowed to come into the campus. But as from my information, okay, from the, I think after we have been briefed, okay, if not mistaken, so the class will be still continue online. Okay, even though you are allowed to come into the campus, okay, starting week 9, but the class will be fully online. Okay, so meaning that you are streaming, you will attend the class online. So we are continue this way until the end of the semesters. And for the final exam also, this semester still will be carried through online platform. Okay, for the final exam also. So final exam online meaning that what? So meaning that your class is also will be in full online. Okay. Okay. So today, I hope you have already watched the pre-recorded video, the Transformer Part 1. We also for semester 3 already. What do you mean by semester 3? For semester 3. What do you mean by semester 3? Online for semester 4. Oh, okay. That's true. Actually, most of the lecturers have saturated already. Okay, they are we are getting bored with this kind of online assessment, online class, and so on. During the first semester, yes, we are excited because this is new for us, new experience. The second semester also, but for the third semester, the burden for the lecturers, I think for the students also, is actually increased time to time because there are a lot of procedures coming in. Okay, because of the previous experience, so on. So there are a lot of new SOPs, new procedures. For example, for the online examinations, the preparation, the documents is actually quite amazing. Okay, we need to have a lot of documentation that need to be prepared. So that's why we are hoping that this is the last semester for the online assessment, online class, and so on. And pray for that. For the next semester, we are in face-to-face mode. Okay, after 3 semesters, I think already 4 semesters. I think 4 semesters. The other first semester, the first one is actually at the middle of the semester. We are going face-to-face, and then I think March 2020 we start um, going into the online. Okay, because uh, I remembered about March 2020 because I actually in Bali, Indonesia at that time. Okay, with my family, and then we arrived in KL. Okay, on 18th of March, the day where we first have our PKP. That is we arrived at KLIA on that day. Okay, so that's why I remember the date, 18th of March 2020. Okay, so we move on the Transformer Part 2. Okay, so Transformer Part 2 is actually more on the testing of the transformer. So the purpose of this testing is actually to what is the objective? Okay, so the objective of transformer testing is the first one is to find the parameters of the transformer. Okay, so this is actually a single phase transformer. Okay, this is a single phase transformer. Okay, so there are two testing. The first one is what we call the no load, and the second one, Benny, can you answer my question? What is the second test? Benny, are you there? Tak ada. Fazli, what is the second test? The first one is no load test. Oh, tak ada juga ni. Imran?
Short circuit test.
Okay. So, okay, thank you. Short circuit test. Okay. Okay, no load test and short circuit test. They are used to find the parameters. For the no load test, what is the parameters that we can get? Okay, so we have this transformer equivalent circuit. We have R. This one is R core. This one is magnetizing inductance. And then we have R1, or sometimes also we call this as R equivalent. And then we have this one X equivalent. Okay, this is the simplified where the R equivalence. This is R equivalent 1 and also inductance equivalent 1. Why is 1? Because we are referring all the parameters to the primary winding. Okay, so R equivalent 1 is you have R1 plus A square R2. Okay, and you have also X equivalent 1, which is X1 plus A square X2, right? Okay, so for no load test, what parameters that we can obtain from the no load test? Okay, so you have, example, this one you have a voltage source. Okay, so this one is your IO, this one is IC, this one is IM, this one is I1, and this one is I1 prime. Okay, so for no load test, what is mean by no load test? For example, if you have a simple circuit, right? You have a simple circuit, you have a voltage source, okay, and then you have a terminal load, okay, and then you connect with a load right now, okay. So when you have a load, there will be a current flow, okay. The current will flow when you connected with a load. But what happened when we disconnect the load? Meaning that there is no load connected. What is happened to the current? Is it there is a current flow? Yes, the current is 0. The load current is 0, meaning that this I1 prime is 0. Okay, is 0. So meaning that, what is mean by that is that if you have a voltage source, you connect with a voltage source, and then you measure the voltage by using voltmeter. Okay, and then sorry, voltmeter. It's not voltmeter here. Voltmeter, which is you need to connect parallel, and then you also need to have an ammeter. Okay, so ammeter, for I hope you have already been exposed that in electrical engineering, the ammeter, we are to measure the ammeter, we are not using ammeter. Okay, we actually use what called the clamp. We clamp the cable, and then this one connect to the ammeter. Okay, we use a clamp. Okay, there's a tools lah, kita pakai clamp. Okay, so you need to hold the clamp, so the clamp will actually generate the readings for the ammeter. Okay, so ammeter, and then also we measured the power. The wattmeter used is actually will give you the reading of only P. Okay, there is no Q, because wattmeter is actually for reading the real power. So when you have this testing no load, meaning that I is 0. Okay, meaning that if you have a voltage source, so there will be a current flow here, and then this current is actually flowing, is I1 is actually equals to IO, because this one is 0. So meaning that your functional sticky is only this one. Okay, you have RC, RC and also XM. That's why to obtain the RC and XM, we use the no load test. So you can obtain your RC and XM. Okay, how to obtain RC? So you refer to my notes, okay? Because this you have the wattmeter P, You have the voltage, and then you have the current. To obtain, you know that power is equivalent to V square over R. So right now, the power that measured is actually the power that absorbed by this resistor. And the voltage, that the reading of the voltage is actually the voltage across the resistor. So that's why we can use this equation. Okay, so this one is your VR, okay, which is the reading of the voltmeter. So, and then the power is actually the power absorbed by the RC. So that's why we can calculate your RC based on these values. Okay, so your RC is equal to V square over, okay. And then to get your XM is by using, since we know that this voltage is also equals, okay, the reading of the voltage is also parallel with XM. So you can use the voltage reading over, sorry, you know that your Q, okay, your Q is equal to V square over XM, right? P is this one, while Q is this one. Okay, and the voltage here is actually, you can use the reading voltage because the same voltage is across the XM here. So your XM is V square over Q. But right now, the readings only P, voltage and current. There is no reading for Q. Okay, so how to obtain the Q? Okay, so we need, you know that Q is actually V multiplied with current multiplied with the sine theta. So right now the voltage is actually the reading. The current is also from the reading. The only parameters that are still not available is the sine theta. But this theta can be obtained from, we know this one, V I cos theta, right? And this one is actually come from the reading. This one also from the reading. This one also from the reading. So from here you can get your theta, which is cos inverse of your P over magnitude of voltage and also magnitude of current. Okay, so that's all for the no load test. Or sometimes also we call this one as a, since this is open circuit, so this one also we call open circuit test. Okay, so no load or sometimes also open circuit test. Any questions on this? I hope you understand, because after this we will go for the final exam sample questions. Okay, so this is actually the parameters that you need to know, P and also Q. Okay, P is equals to I square R also can be used. Yes, yes. Sorry. You cannot use that. So, okay, one of your friend asking about whether can we use P is equals to I square R. Okay, so cannot. For this kind of circuit, you cannot use I. Why? Why? Because this readings is actually I O. Okay, this reading of the emitter is your I/O. So what is your I/O? I/O is the summation of I core plus the summation of your magnetizing current. And if you refer to this circuit, the current that goes through the resistor is IC, not IO. Okay, but the reading here is IO. Okay, So you got what I mean. So you cannot use this I. You need to get this. Actually, the reading of this power is actually your P core. Okay, the losses of the core. So meaning that the current that you need to use here is the I core, but the current reading here is IO, not I core. So you cannot use this one. You can use this. Why? Why you need to use this? Because the reading of the voltage is actually, as you can see, is actually because RC is parallel with the voltmeter. So the reading of the voltmeter is the voltage across the resistor. So that's why we need to use this. Okay. That is very good question actually. Okay, so I hope you are clear. One thing that I want also to maybe share with you is actually on how you using the equation of the power. Okay, so for me, if you have like this, is it so very? If you have like this, for example, resistor, okay, and then you have a voltmeter, and you have the ammeter here, and also wattmeter, okay, wattmeter, and then you have, for example, inductor here, okay. So which one to use? You have two equation power. You have I square R and P is equals to V square over R. For parallel connection, better to use this one for parallel because the voltage here is the voltage across the resistor. Okay. If you have a series connection, okay, there's a current flow here, example I, okay, this is your R, this is your X. So to calculate what is the power, for example, the whole circuit, what is the power? So which one that you use? For series, don't use this one. This one is totally wrong. If you use this to calculate your power in series connection, it is totally wrong because usually the voltmeter here usually will actually read actually all the voltage drop across these two elements. Okay, while P is actually only absorbed by resistor, so you cannot use this one. You need to use this one because the current here, the reading of the current is the current that goes through the resistor. So you need to use this one. Okay, so please bear in mind if you are experienced or facing this kind of questions, look at the type of connection. So if the resistor is actually, if the connection is parallel, use this one. If the connection is in series, use this. Okay. 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 This is for the no load test. Okay. And for short circuit test, is actually to get your R equivalent and X equivalent. Okay, the series parameters. This one RC and XM we call them as parallel elements, while R equivalent and X equivalent is actually the series element. Okay, so banyak nak padam ni. So this one is very important, okay? X equivalent is x1 plus a square x equivalent. Sorry, not x equivalent. This one is x2. Okay, what is a? Is actually the number of the ratio. Okay, so for short circuit test, so for example, you have a voltage source, and then you have RC and also XM. Okay, and then you have R and also R equivalent and X equivalent. So meaning that this is the load, so you short circuit. Okay, so you short circuit it. So when you short circuit this one, based on the analysis that have been done, so actually the RC and XM actually can be ignored. Okay, and can be ignored because the effect is very minimum. So meaning that all the readings, for example, the voltage readings, the current readings, and the power readings is actually referring to the all this one. Okay, so the voltage reading here right now is the voltage across this one. So okay, and the current is also the current that flow inside this resistor. So meaning that you know that Z, okay, Z equivalent is equals to R equivalent square plus X equivalent square. Okay, and from here you can calculate your impedance values by using the magnitude of the voltage reading over the current reading. Okay, the magnitude. Okay, so you can get your Z equivalent. So this one also is also only magnitude. Okay, so that is the first step for the no load test. For the short circuit test. You obtain the impedance first. And then we know that you need to calculate R equivalent and X equivalent. And usually X equivalent is very difficult to calculate. Okay, so the easiest one is the R equivalent because you have power, voltage, and current. So you can extract the information of the resistor from power because we know that the power is actually equals to this one is a power. So this is the series connection. So you need to use I square R. Okay, because this is series connection. So the power reading, so meaning that you can calculate your R equivalent. So this is your R equivalent. The reading of the power over your I square reading. Okay. Then after you obtain your R equivalent, then you substitute this one. So, and then you have already get the Z equivalent. You have already get the R equivalent. Then you can get your X equivalent. So that is actually how we do the parameters calculation. Okay. Based on the no load test and the short circuit test. So why we need this information? Why we need to do the test to get the RC, XM, and then R equivalent and X equivalent? So and then what is next? Why we need this one? Why we need these parameters values? Okay, why? Why we need these parameters values? After we obtain this one, what we need? What can be done? Okay, what can be done? This is actually modeling. Okay, this is what we call modeling. So we model the transformer, the physical transformer, into an equivalent electrical circuit. So the to get the circuit, we need parameters that can represent the actual transformers. Okay, to get the parameter, so we need to do this test. So we need that for that particular transformer. So because the transformer is different, okay, so we need to do this test. For example, transformer A is actually different to transformer B. Okay, so they are not identical. So because they have their own characteristic. So we need to do this to do this test to get the what is the R equivalent, what is the RC, and so on. So after you get the parameters, then you can do simulation. Okay, we model this one because we want to do simulation. So meaning that you can do the analysis, okay, by doing simulation only. Okay, from that we can actually save costs and so on, and then we also can be very in a very safe condition because we are not dealing with actual transformer, because sometimes because we don't know the characteristics of transformer. So when you put some voltage or some current, very high voltage, very current, so maybe the transformer will explode or maybe malfunction, we don't know. So it's better to do the simulation first, okay, analyze the performance of the transformer and so on. So that is what the purpose of modeling. Okay. So it's very crucial to get the actual parameters value that can represent the actual transformer. Okay. So I hope you can follow me on this transformer modeling and so on. Okay. Do you want to discuss about the example from the slide? Have you any questions regarding the examples? For example, this one. Okay. So, any questions? I think we go for this example 4 first, and then for that exercise from the final exam. So try to do that first, and then I will actually share with you the solution. Okay. Okay. So I think we go for this one, example 4. Usually when I use, okay, this one I think the last version of Microsoft with Whiteboard right now, so it's very easy. I can cut paste this one. Okay, I can just cut paste this. I don't know, but I have already updated the Microsoft Whiteboard, but somehow it goes back to the original version. So I'm happy with that because the original version is very easy to use. I can just cut paste any, for example, the I just snapshot, for example, this PowerPoint, and just drag in. So it's good. But the newer version of the Microsoft Whiteboard is very unuser friendly. User not very friendly lah for the newest version. Okay, actually, this one is quite similar to what I have discussed. Okay, but maybe there are some tricky information there. Okay, so please look at the examples. So obtain the equivalent circuit of a 200 and 400 volt. So 200 meaning that 200 is actually at the primary side, and the 400 volt is actually on the secondary side. So this is a single phase transformer, and the following test data is obtained like this. So for the open circuit test or no load test, you obtain the reading of the voltage 200 volts. The current reading is 0.7 amperes and the power reading is 70 watt. And look at this one. This data is taken from the LV side. So what is the LV side? It's actually the low voltage side. Okay, and the short circuit test, the reading here is actually taken at the HV side. So HV side is meant by high voltage side. So what is meant by low voltage and high voltage side is depend on which one. It's not primary, it's not depends on the primary and the secondary. It's actually depend on the voltage. Okay. So as you can see right now, for this transformer, this is a step up transformer. So this is your low side voltage and the secondary is your high side voltage. Okay. So for the open circuit test, the data is taken from the low voltage side. What is mean? Meaning that you have a voltage supply. So, and then have the voltage reading, you have the current reading, and also you have the wattmeter reading. Okay. And then this is your RC. And then this is your XM. Okay, so this is your primary side, and then this is your secondary. So this one is R1, this one is your X1, this one is your R2, and this one is your X2. So right now, this is your low voltage side, this is high voltage side. Okay, so when it said that the data is taken from the low voltage side, meaning that the high voltage side is open circuit. Okay, so meaning that this one, so since this is open circuit, the current is zero. Okay. Oh, okay. Sorry. I'm sharing. Yeah, I'm sharing the whiteboard right now. Can you see that? Yes, I'm sharing the whiteboard. Yeah, okay, thank you. Okay. So I is equal to 0, I2 here. This is I2. 0, so meaning that this one is your I1 prime, so this one is 0. Okay, so 0 meaning that the current here is actually only flow to RC and also XM. So meaning that this is not functioning, so you can ignore this circuit. Okay, all the reading actually referring to the RC and also XM. Okay. Okay, I think this one is okay. The second one, the short circuit test. Okay, so the short circuit test, the data is taken from the high voltage side. Okay, to the high voltage side. So this one, for example, I have this. So this is your R equivalent to, okay? And this is your X equivalent to. Okay, C is from this one is low voltage and this one is high voltage. So the reading is taken, meaning that you have a voltage source here, okay, and then you have the wattmeter here, you have the voltmeter here, and then the current here. Okay, but the short circuit is happening at the low voltage side. Okay, you short circuit this one. Okay, the reading is taken from the high voltage side. Okay, so can you see the tricky? Okay, I think these questions, okay, so okay, hold on. I think I just need to refer to hold on. I need to refer to my previous this one. Okay. 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 So this question is not finished yet. Okay. So this is one, and then calculate all parameters referring to LV site. Okay. So this is the information, and then this is actually the question. Calculate all the parameters referring to LV side. So we have the low voltage and high voltage side. Okay. So as mentioned before, okay, for the open circuit test, the parameters RC and also your XM has been already at the low voltage side, right? Because the data is taken from the low voltage side. Okay, so you have the reading voltage, the current, and also the power. Okay, from the open circuit test. So meaning that the RC that you obtain, which is you use P square over R over P, right? And your XM is taken from V square over Q. Okay, so the values is already referred at the low voltage side because the data is taken from the low voltage side. But for the short circuit test, the data here that you obtain based on the reading here is actually the R equivalent that refer to the secondary part, okay, the high voltage part. Okay, so meaning that after you obtain the values, so you use these values. For example, to get your Z equivalent is actually from the V reading. Okay, Z. This one Z equivalent 2. Okay, Z equivalent 2. You got the from V reading over I reading. Okay, and then you obtain the R equivalent 2 from P over I square. Okay, and then you can obtain your X equivalent to from this formula. Z equivalent to minus R equivalent to. Okay, so all the parameters here is actually R equivalent to and X equivalent to. But the question is parameters referring to LV side. So what you need to do is actually, if you want to refer to the LV side, what you need to do? You need to multiply with the turn number of ratio. Okay, so R equivalent 1 is A square R equivalent 2. And your X equivalent 1 is A square X equivalent 2. Okay, meaning that after you obtain these values, so you need to transfer to the lower LV side, you need to multiply A square. Okay, that is the only tricky part. For the final exam, the sample from the final exam is actually in reverse. So for example, you obtain the data from for example, the R equivalent 1 and R equivalent 2, you need to refer to the low voltage, to the secondary part. So if you have that question, okay, so what you need to do is actually to get your R equivalent 2. So from R equivalent 1, you need to divide by A squared. And the same to go to the X equivalent 2. So you get the X equivalent 1, so you need to just divide by A squared. Okay? The same case goes to the RC lah. RC pun sama. So RC at the second pun is actually RC from the primary side, just divide by A squared. And then XM is also same. XM over A squared. Okay? I hope this one will help you. Okay? So I think that's all from me. Any question? Is a value for both LV and HV are the same. What do you mean by value? Value. You mean, is it referring to the parameters? If you said so, so it's not similar. Okay, if you obtain this one, it's actually the readings is actually from the high voltage side. So if you transfer back, so it's quite different. You need to multiply A square because this primary and secondary is actually you have a ratio. For example, this one 200 over 400, right? So it's quite different. So meaning all the reading of the voltmeter, the reading of the current is actually different because we have this step up ratio. Okay, so the values R and X equivalent is also quite different if you transfer to the primary side because it depends on the voltage and current. Okay, because voltage and current you have actually multiplied kan 2, so that's why you got higher values of R equivalent and S equivalent 2. But when you transfer back to the primary side, it will become lower than that because you need to divide back because of the number of ratio. Okay, if the primary, second, and if the primary and the secondary have a same ratio, for example, 200 and 200, then okay lah. So because this one, A square, what is A square? So what is A? A is actually N1 over N2. So if you have a same ratio, then your A or A square is 1. So meaning that the R equivalent 2, for example, is R equivalent to is 20 ohm. So when you have this ratio is similar, is 200 and 200. So meaning that your R equivalent 1 is also 220 ohm. No big deal. Yes, R equivalent 2 is equal to R equivalent 1. If the ratio is equal. Okay. I think from the previous class, I have already mentioned about the main two functions of the transformer, right? The first one is for isolation. And the second one is for step up or down. And usually step up and down, so meaning that you have your A is smaller than 1, and step down A is larger than 1 because A is equals to N1 over N2. Okay, for the isolation, A is equal to 1. Okay, so if you are using your transformer just for isolation, so your ratio usually is actually equal to 1, meaning that there is no step up or step down. Okay, because you are using that transformer for electrical isolation only. Okay, so actually this transformer equivalent circuit, okay, you have already obtained this one RCXM, right? RCXM, and then you have R1, and then you have X1, and then you have a winding, and then this one R2, and then X2, and then the load. Okay, so actually this circuit is actually the same circuit that we model for the AC motor, because AC motor we have stator winding, right, and then we have a rotor winding. So as you can see, you have two parts. This one is just a primary, but and then this one is a secondary. But the difference between transformer and motor is actually the rotor is actually rotating. Okay, rotating. So actually the circuit is actually similar. Only this one, the load is actually we have what called torque equations lah. We have torque and then we have speed equation and so on. Okay. So actually the transformer is the basic principle of the AC motor, but the difference is only the motor they have a mechanical output, but the transformer is used to convert the electrical for step up or step down. But I want to mention again, this is also very important. The power input of the transformer is equals to the power output of the transformer. Meaning that if the source supply 500 watt, the power output is still 500 watt. If no losses lah, if the transformer is ideal, no losses, then your P1, P input should equals to P out, even though you have a step up transformer. Okay, for example, this one, this one N1 is 200 and your N2 is 400 volt. Okay, so you, even though it step up the voltage, okay, the power will still remain the same. Why? Why the power is still remain the same? Because you need to know about this equation. N1 over N2 is equals to V1 over V2, and this one is equals to I2 over I1. Okay? So meaning that if you have V1 200 and V2 is 400, so you can calculate you can see that the current will actually lower. Okay, for example, 500 over 400. Okay, 500 watt over 400 watt. Okay, 500 watt over 400 volts. So the current here, I secondary is 1.25 amperes. Okay, and the I primary 500 watt over 200 volt is 2.5. You can see. Okay, so even though you step up the voltage, but the current will go down. Okay, so the current will go down from 2.5 to 1.25. So as you can see, even though you step up, the current will go down. Yes. So actually the transformer is used to step up voltage and step down the voltage. It cannot use to step up the power because we cannot create the power. The transformer is not used to create. Okay. The power can be only created by the source, but the transformer is not the source. It's not energy source. So it can only convert. Okay. But the power will still remain the same. It can only convert the voltage either to step up or step down. Okay. But the power should be remain the same. So that's why we have this relationship. If you want to step up the voltage, then the current will go down. Yes, conservation of power. You cannot create power. Okay. Okay. I think several years ago, they because in electrical power, usually we create power using generator. Okay, where you use gasoline or you use hydro water. Okay, to create the rotation of the turbine, and then it will actually create current and voltage. But several years ago, there are some novel work where we can create electrical energy from the magnet, okay, from a permanent magnet. But I don't know why there is no continuation on that research. Yes, this course will cover transformer three phase. But as mentioned before, our main concern is on the single phase transformer. Okay, so meaning that so this one is the test, and then after this, after the semester break, will we go for the efficiency? So how to calculate the efficiency of the transformer and then the regulation of the transformer. After that, we will go for the auto transformer. So this is also just a very brief, and also three-phase transformer, also very brief. Okay, but our main is on actually on the single-phase transformer. Okay, so this is only brief saja, because the syllabus of this course is quite extensive, so we don't much have to cover time. And then among the lectures also, we have agreed that our main concern or main important part is actually to expose mainly on the single phase transformer, and then the other part is just a brief surface only. So meaning that you just know what is a three phase transformer, what is the auto transformer, and so on. Okay, I think that's all. I think please do since you have 1 hour more, so please try to do the exercise that I have provided in the WhatsApp group. And for this topic, there are not much reference book that you can refer to, because actually there's no quite orang kata apa, very suitable textbooks lah, because this material is quite outdated, but we need to offer to the student, or still we need that this syllabus to be inside. Okay, if you go to other outside Malaysia, so this usually they are not offering this course anymore, but the regulation of our accreditation, they require this. Okay, so that's why we don't have books that we can refer to. Okay, so itulah, that is the problem. Okay, because some examples in the textbook, they are go deep. They are deep. So the syllabus is not covered in our course. So that's why. Okay, so if there is no questions, any questions? So if there is no question, then we dismiss this class, and please proceed with the try to solve the problems, the exercise lah, that I have already shared. Okay. So thank you very much for your time, and have a very good day. Assalamualaikum.
Waalaikumsalam.